Welcome to lesson 29 of our Math 135 course. Today we're going to take our second lesson into sequences and series, and today we're going to try to focus on one of the specific types of sequences and series, and that is arithmetic. Now, I know you might look at this word and say, well, that's a pretty bad math teacher. She can't even pronounce arithmetic. Now, I don't know who decided this, but most of the time we do pronounce it as arithmetic when we're talking about the sequences and series. Sorry, not my fault. Now I want to start out with a problem because I like to appeal to your common sense. So, knowing how lots of us have trouble saving money, I decided that here is a scheme to help you be a better saver. And you're welcome to steal this idea if you'd like. This week, you're going to deposit $5 into your savings account. Next week, you're going to deposit $5.50. And the third week, you'll put in $6. And then the fourth week, it'll be $6.50 and so on, right? We're going to keep increasing our deposit every time. Hey, and I did say we're going to ignore interest totally on these problems, although it would be really fun to go back and do some interest, but I'm not going to at this point in time. Because, you know, our big concern is getting you to save the money, right? The interest is just icing. Now, following this particular plan, how much will you deposit in week 20? Okay, so let's look. Here's week 1, here's week 2. You know, this almost looks like the sequence with subscripting for my terms. Kind of does, doesn't it? I could even write that as a subscript. Week 4, and I would like to know, without writing them all out, what would be week 20? Any great idea? Well, let's think about this. Each time we're adding 50 cents, we're adding 50 cents, we're adding 50 cents. So how many times will we add on 50 cents? Now your first guess might be 20, but wait a minute. To get to week 2, we added on 50 cents once. To get to week 3, we added on 50 cents twice. Oh. So how many times will we have to add on 50 cents to get out to week 20? It'll be 19, won't it? So we're going to add 19 times 50 cents. But we're going to add that on to what? Well, we're going to add it on to our beginning amount, which was $5. So this is what week 20 should be. And let's see here. I believe that's $9.50 if I'm doing my arithmetic right. So we should have 5 plus the additional $9.50. That week we should deposit $14.50. Okay, that sounds cool. Question B. Following this plan, how much will you deposit for the week exactly 1 year later? Now, by the way, when I say 1 year later, I mean 1 year later than when you started. So 1 year later would be week what? Now, I would call it week 53. Now, I call it week 53 because the 52nd week would be the last week to complete your year. And then 1 year after your first week would be the beginning of your second year. So I'm going to take that as week 53. So to get week 53, I sure don't want to write out the first 52. I could, but who wants to? So I'm starting at $5. And then I'm adding on. Now, how much am I adding each time? I'm adding 50 cents each time. Now to get to the 53rd term out there, how many times will I have to add on the 50 cents? I'll have to add it 52 times. Are you okay with this reasoning? I hope so. So 50 cents times 52, that's $26. So 5 plus my 26, we're putting in $31 the first week of our second year. Well, you know, that's not a lot, is it? I mean, it's not. It's helpful. It's very helpful. So maybe we could do this, huh? Well, let's continue with our ideas. Following this particular plan, how much will you have deposited in total for the first 20 weeks? Well, let's see here. For the first 20 weeks, I would have had $5 plus $5.50 plus $6 plus $6.50 plus 7 plus $7.50. And so on. And let's see here. We figured the 20th week was $14.50. So I'm going to put him over here. That's the 20th week. How much would we have put in week 19? The week before? Wouldn't it be 50 cents less than that guy? So it'd be $14. So here's what I need to do. I need to sum all of that up. And just because I love subscripts, I'm going to say S sub 20, because I'm adding up 20. And I could grab a hold of a calculator and I could say 5 plus 5.5. Oh, but there's a better way. Well, to get an idea of that better way, I would like to tell you a story. And I apologize if you've already heard this story, but it's a good one. It's the story of little Carl Friedrich Gauss. And Gauss is considered by many historians to be one of the 3 greatest mathematicians of all time. And you might want to email me about those other 2 guys. But anyhow, little Carl Gauss is a rather sharp young man. And the story goes that he's sitting in elementary school. And by the way, there's a wonderful biography on Carl Gauss called The Prince of Mathematics, written by Margaret Tent, T-E-N-T. And she verifies that this story is probably what happened. And his teacher has kind of taken a bum rap of deciding to keep the kids busy and quiet for a while. So he tells these little elementary children, and this is even pre-calculator days, add up all of the numbers from 1 to 100. And then give me your slate. They were actually writing their answers on slates. Well, of course, now the teacher's got all day to rest and relax as the kids are trying to do that, because of course the kids are going to say 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. They're going to be there a long time. And what's the probability that they make a mistake? Pretty high, right? Well, little Gauss just sits back and looks at this. According to Miss Tent, he really looks at it and thinks about it, and then he writes down the answer and puts his slate up on the teacher's desk. Not surprisingly, he's the only one that has it right. And by the way, his poor teacher takes a lot of a bum rap on that little story, but his teacher also recognized how amazingly brilliant this young man was, and he did, really try to help improve his mathematics education. But here's what little Carl Gauss figured out in elementary school. If I add up the 1 plus 100, I get 101. And if I add up 2 plus 99, I get 101. And if I add up 3 plus 98, I get 101. And then you, of course, ponder, well, is this a coincidence or should this happen? Well, should it? Well, notice that each of these are getting bigger by 1 and each of these are getting smaller by 1. Well, yeah. So then how did Gauss get the answer? Well, I have 50 pairs of numbers, each of which add up to be 101, so 5,050. That's what they add up to be. Lovely idea. And I tell that story every time I teach this particular idea because to me it's a wonderful way for remembering how this is done. Because now when we go and look at our savings problem, I say, well, will it work here? Let's see. If I add up $5 and $14.50, I get $19.50. Well, if I add up $5.50 and 14, I get, looky there, $19.50. And again, you want to think about this. Is this just a coincidence? Well, no, because each of these numbers is increasing by 50 cents. But meanwhile, coming from the top down, they're all decreasing by 50 cents. It has to happen. Okay, so that means that they're adding up in pairs to $19.50. So all I need to know is how many pairs. Well, let's see here. How many pairs will I have if I'm adding up 20 numbers? I'll have 10 pairs. So guess what? I didn't have to do one single addition. Well, no, I did one, sorry. And I get $195. I added up the first term and the last term and then multiplied, and I find very quickly and really quite simply that within the first 20 weeks, we have deposited $195. Well, that's kind of nice. And you know, now you start to feel like, ooh, I have a little bit of money in my savings account. Yay. Well, if we follow this plan, how much will we deposit within the first year that we're doing this? Well, I'm going to have the same kind of a setup. We would have S sub, let's see here, if it's for the first year, we're going to do 52 terms, right? And this is, again, a partial sum. And I have $5 plus $5.50 plus $6 and so on. Now, what do I need to find? Well, I need to find out how much that was in the 52nd week, okay? And just to make it nice, I should probably also find week 51. Just to kind of double check myself on my arithmetic. So let's see here. To get to the 52nd term, actually, you know what? This guy will be easier for me. I'm going to do this guy. To get to week 51, and I'm wanting to know how much I deposit just in that 1 week. Let's see here. I'm starting with $5. And what are we doing with that $5? Well, we're increasing every week by 50 cents, right? Okay, and to get out to 51, we have to add this on how many times? We have to add it 50 times. Okay, well, that's going to be 25. Yeah, I realized that arithmetic was going to be nice. 25 plus 5, it's $30 here. So the next week it's $30.50. Okay, so I know now a little bit about how I'm depositing my money. To get my sum for that entire year, I use the little Carl Gauss story. I love the Carl Gauss story. My sum is going to be, add up the first and the last. That's $35.50, right? And by the way, I see another $35.50, so I feel real confident. It's $35.50 times, well, how many pairs do I have for 52 weeks? That would be 26 pairs. Now, I think I decided that I didn't want to do that arithmetic, so I went ahead and put that answer here. It's going to be $923. And that's pretty sweet, $923. Now it's really looking like you can start to save money. Okay, well, one more question before we leave our saving money example. In how many weeks from the beginning will your deposit be exactly $100? Now remember, that's $100 for that week. And you might decide that by the time you get there, well, I don't think I can put in $100 a week. But you might have worked yourself up to a level that you feel comfortable that you can maintain. So let's see here. The question is really, as we go out this sequence, because you know I'm not asking what's the total amount of money. I'm not asking you to add them up. I'm asking for a particular term. I want to know how far out there until we hit 100. That's going to be week what? I called it N, week N. Well, let's see here. To get to that 100, where did we start? We started with 5. And what did we do? Well, we kept adding 50 cents. Now, how many times did I add 50 cents? I don't know. But if I call this week N, I added 1 less than the week. Remember? It's always lagging 1 behind. And you know, sometimes I forget that, or I used to forget that before. I've taught it so many times. And so I would just kind of refresh my memory by kind of double checking. How many times did I add 50 cents? How many times did I add 50 cents? To refresh your memory, oh yeah, I'm always lagging 1 behind. So I would have, by the way, subtract that 5 over, 95 is equal to 0.50 times n minus 1. So 190 is equal to n minus 1. So what did we find? In week 191, you will deposit exactly $100. Now, is that like 10 years down the road, or how many? 52 weeks in a year? Less than 4 years. Sometime in that 3rd year, you would be hitting that $50, and you might, the $100 a week. You might decide, I better stop increasing anyhow, not saving. Now, by the way, we have a formula here for finding a sub n. What does this mean? This means finding the nth term. And a note we need to make is this is when we have what we call an arithmetic sequence. I'll just write over it. Arithmetic sequence. And what makes it arithmetic? It is called arithmetic when I add the same amount, add the same amount, add the same amount to go out term by term. Now, to find that, think about what we did each and every time. We had the starting point, and the starting point was always the first term, right? Makes sense? And then we had a certain amount that we were adding every single time. And then this represented how many times we had to add it. With that in mind, here is the formula that you come up with for finding the nth term of any arithmetic sequence. So if you have an arithmetic sequence going on, then if I want, let's say, a sub 102, I start with the first term and I add on and minus 1, I add on 101 times d. And you say, what is d? Well, d is called the common difference. The common difference is that amount that you're adding on each time. So in the case of our example with saving money, our common difference was 50 cents. And we'll do some practicing with these guys. Now to find the sum, and this is a partial sum, we're not adding up infinitely many, we're going to add up n. And that's where you use the little Carl Gauss idea. You add up the first guy and the last guy, and then multiply by how many pairs. And guess what? I can spit out this formula now, because I've used it so many times, but really in my head, it's stuck there in those words. The first guy plus the last guy times the number of pairs. And just to honor Mr. Gauss, I went ahead and grabbed a picture. That was in 1803 when he was a younger man. It was the youngest one I could find. And I thought this was kind of cool. This is a 10 Deutschmark. And I don't know from what year, but he was so important, he was on their money. And he's been on stamps and so forth. He's a pretty important guy to know. So if you want, read Tent's biography on the Prince of Mathematics. Now, let's go ahead and find some sums. We did a little bit of this in the last lesson, and you know what this sigma means. It means I'm going to add, and it means I'm going to start with k being equal to 1. So if I let k equal 1, this ends up being 2. Then I let k be 2. Would that be 5 minus 6? I get a negative 1. I know I don't have to put plus negative, but we might want to in the beginning. If k is 3, I have 5 minus 9. I get negative 4. And you might start to see the pattern and not need to write more. I'll write one more here. If k is 4, I have 5 minus 12. I get negative 7. And this is going to continue. And it helps to have the last guy. And the last guy happens where k is 12. 5 minus 36 would be negative 31. Now, in order to use that lovely formula that we stole from Mr. Gauss, of course, actually the teacher did know that formula, but he had studied it in college. He hadn't discovered it by himself in elementary school. But you need to determine if this is arithmetic. What would you add to 2 to get to negative 1? I know that seems a little bit weird, but you'd be adding a negative 3, right? And what do you add to negative 1 to get negative 4? You would add negative 3. And here you add negative 3. And since you're adding the same thing each time to go from term to term of the sequence that we then add up in this series, then that means this guy is arithmetic, and the common difference is equal to negative 3. Okay? Then I can use my nice little formula, and I can say first plus the last is what, negative 29? So I would have negative 29 times, now how many pairs would I have if I write them all out? I have 12 numbers. So I'd have 6 pairs, and 6 times negative 29 is what? Negative 174 maybe? That's what those 12 numbers will add up to be. Kind of nice. Okay, well, I threw a little bit of a clink in this guy because I didn't start you at 1. Now, probably 95% of the time, our sums start with k being 1. Well, sometimes they start with 0. Sometimes they start somewhere else. So, start by putting the 15 in for k. because that's where this tells you to start, is when k is 15. So I have 75 minus 11, that's what, 64? Then put in 16. 5 times 16 is 80. 80 minus 11 is 69. Put in 17. We get 85 minus 11, we get 74. And I kind of see a pattern going there. I hope you do. Now, because I know that this is add 5, I know he's arithmetic. Now, of course, if you're not real comfortable with these, you might need to write a few more terms till you're sure. But then put in the 57, and we get what? 5 times 57, which is 285 minus 11. I think it's a 274 on the end. By the way, if I make an arithmetic mistake here, you just fix that, okay? I think I'm good with it. Well, since he is arithmetic, I can do that whole idea of adding the pairs. So, adding these two outside numbers, I get what? 338. Now, I need to multiply that times how many pairs of numbers I'm adding up. Well, this one isn't totally obvious because, yes, my top number is 57, but I started at 15. So do you realize that I didn't have the first 14? So 57 minus 14, I have 43 terms. Now, I know there's several of you that are saying, oh, she's crazy. 57 minus 15 is 42. Come on, lady, get with it. No, 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 no. You know, on this previous one, we said from 1 to 12 was 12. Well, if I take 12 minus 1, I would get, oh yeah, you don't just subtract those numbers. Essentially what you do is you subtract the one before this bottom number in the sequence. If I do 12 minus 0, yeah, there were 12 numbers in that particular sequence. Another one is, if you go back to just the Carl Gauss story, 1 plus 2 plus 3 plus the last one was 100. Now, I don't do 100 minus 1 and say there were 99. No, there were 100 numbers there. You're essentially subtracting 100 minus 0, okay? So we have 43 terms here. 43 over 2. Now, you know, that brings up an interesting difficulty. You might say, how can you have 21 and a half pairs of numbers? How does that work? Well, look at what's really interesting about our arithmetic sequences. If I have, let's say, 4 plus 7 plus 10 plus 13 plus 16. Now, do you notice he is arithmetic? I add 3, I add 3, I add 3, I add 3. And if I try to get this sum, I add up these two guys and I get 20. I add up these two guys and I get 20. Look at what's sitting in the middle. Half of 20. Oh, it'll always work that way. And you can play with that some more if you wish, but essentially I have no problems with having a half of a pair of numbers. It will work. Now, by the way, I decided that I didn't want to do that arithmetic in my head. I think my eraser has gone totally to sleep here. Okay. And the actual sum there is 7,267. So if you want to check your calculations, that's what you should get. Okay? Well, we got one more guy here to do. We're running from 1 up to 6. Oh, and you can see we have k's in several places. When k is 1, I get 0 times 3. So I have a 0. For the second term, where k is 2, I have 1 times 4. I get 4. When k is 3, I get 2 and 5. And I get 10. Now, by the way, I only have 6 to write, but I'm also noticing 0 going up to 4. I'd be adding 4. Yeah, this guy's not arithmetic, is he? Okay. When that was what, 1, 2, 3. Now I need where k is 4. That'd be 3 times 6, which is 18. And when k is 5, I would have 4 times 7, 28. And the last guy where k is 6, I have 5 times 7, I'm sorry, 5 times 8, and I get 40. And if you take a look at that, as I said just a moment ago, add 4, add 6. Now there's a lovely little pattern going on here, but it is not arithmetic. So if it's not arithmetic, how do you get the sum? Well, I can just add these guys up. And I want you to always be paying attention. Don't just randomly start applying formulas. Make sure that you have the correct kind of sequence. Our next lesson is going to look at this second special kind of sequence. And so right now, you only have arithmetic as special sequence. But before you use those two formulas, verify that you do have an arithmetic sequence. And if you don't have an arithmetic sequence, then hopefully you have few enough terms that you can simply add that up. And I don't think that's too bad. That's what, 46, 50, 60. Oh, we get 100. And if it's a really long sequence, well, then you might need to go investigating some of our other techniques. Okay? Now, let's express the following guy in summation notation and actually find that sum. Well, is he arithmetic? Because if he's not, we're almost dead in the water. Let's see here. What do you add? We add 11. Add 11. Now, by the way, I'm not going to give you a tricky situation. If that's all we give you, you are to assume that pattern continues. So it is going to be arithmetic. Okay, cool. So I'm ready. Well, I need to write it as summation notation. No, you know what? I'm going to skip that summation. Because of time, I think I want to just go ahead and write what the sum would be. Okay? I need to know which term this is, because I know that as I sum this up, I'm going to add the 8 plus the 16,805, but before I can do that, I need to know how many terms there are. So how do I do that? Well, I use my A sub n formula. You know, you start with the first term, you're going to add the common difference n minus 1 times. Now the reason I do that is I know my common difference, he's 11. I know my first term. I know this term way out there, and then I can find the n. Because out of 1, 2, 3, 4 unknowns, I know 3 of them. So I can say 16,805 is equal to 8 plus n minus 1 times 11. Easiest way to solve that is to subtract your 8 across. So 16,797, I believe, is equal to 11 times n minus 1. Oh, then we get to divide. Well, I believe that's 1527. Not too hard to divide by 11. And then add your 1 over. N is going to equal 1,528. Wow! So that's pretty amazing. I'm adding up. This is A sub 1528. So now I know I'm trying to add up that many terms, and it would be 1528 divided by 2. And I really didn't want to do that arithmetic in my head. My eraser is still not working. It is over 12 million. Aren't you glad we have a shorter way of doing that? I am. Okay, this looked like a fun problem to do. So, you want to go see your favorite team. Now, we all know mine is the Steelers, so they're playing in the Big Sombrero down in Tampa Bay. And so I'm looking at the seat arrangement. I hope they don't mind that I stole it from their website. They've got a beautiful stadium. And you notice that you've got these interesting arrangements in the corners. You kind of have these wedges going up through there. And in fact, what first drew my attention was this little section 217. And if you go to their site, you can drag your mouse, and from that site you can see a picture right here as if you were sitting in that section, and you see that there's one seat in the front, then 2 seats, then 3 seats. Oh, you thought we just made those problems up for nothing in your algebra books. Now, there are seats missing here for the tunnel, and here you've got seats missing, I'm guessing, for stairs. We're going to pretend that those seats are all in there, okay? And even though I had a very nice young man give me some info, I didn't ask him for all the info, so I kind of made some up, all right? So we're going to do a problem to essentially figure out how many seats are in this kind of tan-colored section right here, all right? I thought it'd be an interesting problem, and I love football. Assume that the first row has 6 seats, and then each row after gains 2 more seats. Because you know, for that to get wider as it goes up, they're putting in more seats. Now, it's not 100% consistently gaining 2 every time, so please forgive me. But the young man did tell me we start with row E and we end with row Z. That'll be helpful. How many total seats in that corner section? Now, that's using my very incorrect assumptions. So don't tell the Tampa Bay Buccaneers that I say they've got the wrong number. Sorry. So let's see here. Anytime I'm working with a sequence problem or a series, I like to start writing it out. I have 6 seats in the first row. The second row is going to have 8 seats. And then 10, and then 12, and then so on, right? Now, what kind of series do you see here? I add 2, I add 2, I add 2. When you're adding the same amount each time, that is an arithmetic series. Yay. Because if it's arithmetic, we've got formulas, we're ready to go. We understand how they work. And I want how many total seats? So let's see here. I need that last term, don't I? So that I can do the little Gauss thing. Now, which row is the last row? Well, if we go from E to Z, well, if we went from A to Z, there'd be 26, right? But apparently rows A, B, C, and D aren't there. So we have 22 rows, right? So I need A sub 22. Now, if you're formula driven, I'd kind of like to discourage that, but you can grab a hold of our A sub n formula and you can go for it. But we can just reason it out. To get to the 22nd term, I start with 6. And what am I adding on each time? Well, I'm adding on 2. And to get out to the 22nd term, how many times will I add that on? 21 times. So that's what, 42 plus 6. There are 48 seats across on the 22nd row. Well, I don't quite have my final answer, but my final answer would be the sum of the first 22 rows. And since this guy is arithmetic, it works out beautifully that I can add up the first and the last, the first and the last. And I would get, what, 6 plus 48. And I'm multiplying that times how many pairs I have, which is 11. Well, that would be 11 times 54, which should be 594 seats. If they didn't have to take out seats for the tunnels and everything, we'd have 594 seats in that section. Okay. Well, now I've got this stained glass set up, and we want to look for some more patterns. Now, the customer that you're working this for says she likes this design, but she wants 4 more rows on the bottom. Now, as far as rows, I see here is 1, 2, 3, 4, 5, 6, 7. We have 8 rows right now, okay? Which means we're going to be going down to 12 rows in total. And you only see the first 8. I did that for a reason, because I didn't want you to just count, okay? And so for the design that your customer wants, I want to know how many of these clear pieces you would need to buy and how many of these colored pieces you would need to buy. And again, I don't want you to just simply count them one at a time. I would like to see if we can find the pattern and work it through. So for the clear ones, in row 1, I have 1. In row 2, I have 2, right? Right here I have 2. Then I have 3. And then I have 4. Oh, well, this isn't so bad. How many am I going to have in the 12th row? I'm going to have 12. So by the time you draw out those next 4 rows and you count them up one at a time, I know this is arithmetic. I have 12 numbers. There's 6 pairs. These 2 add to 13, which means we need 78 clear tiles. That was quick. Okay, let's check out for the colored ones. In the case of the colored tiles, the first row I do have 0. And then I've got 1, and then 2, and then 3. Okay, 1 plus 2 plus 3. Now, with that in mind, can you tell me how many I have in the 12th row? You might be able to tell the pattern really quickly. We've got 1 fewer, so my 12th row has just 11 in it. Okay? Well, since I still have 12 rows, I'm going to go ahead and count that 0 as my first term. So I have 6 pairs of numbers, and they add up to be 11. So I get 66. Now, as it turns out, maybe those colored ones are more expensive than the clear ones are. If that's the case, you might like having the pattern in this arrangement so that you can buy fewer of the more expensive tiles. Okay, that wasn't a hard sequence problem by any means. And then I said, okay, I've never done stained glass, but I've seen it, so pretty. And generally, what you do is you have solder on all of these edges, every single edge, connecting the tiles as well as on the perimeter. So with that in mind, how many total inches of solder do I need? Well, again, I don't have the whole picture, so it helps if I can just figure this pattern out. It says in here, or maybe it was on the last one, each one of these tiles is 1 inch. So I have 1, 2, 3 inches on my first row. And by the way, that means I counted this bottom. So on the second row, I need 1, 2, 3, 4, 5, 6 more inches. Then on the third row, I'd have 1, 2, 3, 4, 5, 6, 7, 8, 9 more. You see the pattern? And if you keep checking it, it's going to hold. Can you determine what that last one is going to be? Well, you might realize this is 3 times 1, 3 times 2, and you can use your a sub n formula to find it because you can see this is definitely arithmetic, but 3 times 12, we're going to have 36 in the last row. So a nice quick calculation. Since I have 12 rows, I have 6 pairs of numbers I'm adding. 3 plus 36. So I end up with 6 times 39, or let's see here what that be, 40, 234, I believe. 234 inches. You can double check the arithmetic. Now, to recap our work here with arithmetic sequences, first off, a sequence will be arithmetic if there is a specific number added each time to go from term to term. Okay? Now, to find a particular term, you use this a sub n formula. For those of you that are very much formula driven, you can just memorize the formula. I think this is one that makes total sense, so you can reason it out. And if your series is arithmetic, you can get the sum by using our partial sum formula, the S sub n formula. And of course, I always think of Carl Gauss on that, the idea of adding up the first and the last times the number of pairs, and it goes real easily. Okay? Well, hey, practice and practice with these arithmetics. I hope you enjoy them, and I'll see you in the next lesson.